The Romans called it Mare Nostrum, our sea, always capturing the imagination and encouraging our will to discover. Cradle of Western civilization. Man understood immediately that control over this sea and its natural resources would award them hegemony over the known world. In the early 21st century, many species are in a state of great imbalance due to incessant human pressure, pollution, and overfishing. But this young sea, in geologic terms, is surprisingly fertile, functioning as a global organism made up of millions of living beings closely linked to one another. Animals that range from the mythical colossi to the smallest of invertebrates form a chain in which each link is indispensable for the whole to function properly. The diverse biocenoses are closely linked by the various forms of life that live in its different stratums. Many species, forced by seasonal migrations, cross over its waters or settle temporarily in search of food and mate. Others, who inhabit them, wait for optimal reproductive conditions. Alchemy is produced in its warm waters. The most basic nutrients, gently swayed by the currents, make up the breeding ground for life. All of these beings live together, all cogs in the wheel of the macroorganism that is the Mediterranean Sea, known in ancient times as Mare Nostrum. Years ago, the Mediterranean Sea Basin was an enormous desert valley, with tall mountains forming huge canyons and hypersaline lakes. The Mediterranean we know today was formed a little over 5 million years ago, when the rock dike that had formed in the Strait of Gibraltar collapsed, and the Atlantic came roaring in. Creating the largest waterfall in history, what took millennia to become arid filled up again in just a few years. Nowadays, the Strait of Gibraltar is still an indispensable source that maintains the levels of the Mediterranean, since it loses more water to evaporation than the amount that rivers empty into it. Although not only water crosses through the most transited strait on the planet. Propelled by ancestral inertia, with their warm blood and charged with energy, huge schools of giant bluefin tuna enter the Mediterranean at the beginning of spring to reproduce. During the time of the Romans, 1,000 kilogram specimens could easily be found. Because of this, their meat became the principal source of protein for the legions of empires that have ruled these coasts for thousands of years. After over 3,000 years of fishing, this majestic fish is in grave danger because of international commerce, speculation, and a dismal fishing management system. However, year after year, thousands of reproductive tuna enter the warm waters of the Mediterranean to unload their genetic heritage under the care of the soft currents. And following them, always in ambush, their worst enemy awaits patiently. Sooner or later, they will all have to swim through this bottleneck. Orcas follow the schools of tuna well into the Mediterranean. They hunt in perfectly coordinated matriarchal groups, communicating through echolocation. Each clan has their own dialect, understandable only by their own members. It is the largest of the family of dolphins, weighing in at over 5 tons. Highly astute, they learn from their mistakes and apply new strategies to optimize their hunt. Always in search of banks of smaller fish, other toothed cetaceans such as pilot whales, striped dolphins, common dolphins, and these bottlenose dolphins can be found along the various continental shelves in matrilineal familial groups. Through genetic renovation with neighboring groups, the continuous interchange with individuals that come from the Atlantic is vital, which is why the Strait of Gibraltar, once again, plays such an important role in the regeneration of the Mediterranean. The indigenous population of the bottlenose is particularly affected by trawling, since the fish they catch are the very same species that make up the dolphin's diet. Trawlers also provoke the systematic destruction of the aquatic medium. Like the rest of cetaceans, the sperm whale makes use of a rich variety of low and high frequency vocalizations, using their characteristic clicks to communicate, find its bearings, and locate its prey. Noise pollution and fishing nets are their biggest problem, enclosing and distorting the great blue. This mammal, which can reach up to 18 meters in length, ventures into the most profound canyons of the Midwestern Mediterranean to find and hunt its favorite prey, the great abyssal cephalopods. It can reach unfathomable depths thanks to its highly compressible tissue, as well as to its spermaceti organ, responsible for the unusual and colossal size of its head. Filled with an oily substance, it serves to, among other things, adjust floatability. As it descends, the cold water and pressure solidify this material that acts as a ballast, easing its immersion. Between 45 to 60 minutes later, it heats up the spermaceti, liquefying it to obtain positive floatability and thus ease its buoyant ascent to the surface from over 2,000 meters deep. The sperm whale's diet is made up of diverse species of mesopelagic squid. They are not all from the genus Architeuthis, which can measure over 15 meters long. Most of its prey are made up of specimens that measure between 1 and 5 meters, such as this one, which escaped the powerful jaws of a sperm whale with lethal wounds and somewhat crushed. In the sea, nothing goes to waste. Some scavenger would normally eat up this mass of inert flesh and transform its energy. But most short-fin mako sharks, blue sharks, big-eye threshers, and even great white sharks, which not so long ago inhabited the deep blue of the Mediterranean, are disappearing due to non-selective long-line hooks. Countless pelagic species sway at the mercy of the soft currents along their tireless journey. Planis crabs are easy prey in the vast blue, which is why they seek cover in almost anything that floats. Diverse species of chelonids provide cover for these guests, which grab hold of the folds in their wrinkled skin, and feeding off the various organisms that inhabit the turtle, they keep it moderately free of parasites. Like a floating island adrift in evolution, it drags along all sorts of stowaways, which by their cosmopolitan character could come from very diverse oceans. Fish, crustaceans, mollusks, algae, and the very turtle itself make up a small, errant biotic community in symbiotic harmony, until one of its inhabitants grows too much, rendering it a parasite, which will lead to the long-term destruction of this biosynosis. Although the indigenous population of the loggerhead sea turtle used to lay its eggs along the entire coastline, it now does so in the few virgin beaches that are left in the southeast Mediterranean. Tempted by the drift fishing gear, very few of them arrive at their intended destination. They look for submarine currents that will transport them to where schools of jellyfish, which they feed on, gather. The bodies of these ethereal beings are less than 4% organic material. The rest is just water and the magic of life. They are adapted to wandering along marine highways, capturing small fish and plankton larvae along the way. Cnidaria, a family of corals, anemone, and jellyfish, go through an interesting growth phase. Their eggs turn into benthic polyps, which can reproduce by themselves and become tiny jellyfish that return to marine currents, retransformed as part of zooplankton. Some also serve as protection for young pelagic species, such as the Atlantic horse mackerel and jack mackerel, which develop an immunity to their stinging nematocysts. When they grow older, they'll end up feeding off their host jellyfish. Diatoms are the base of the trophic chain in the ocean. They are the basic food for microcrustaceans and for the larvae of a vast number of species in different stages of development. From lobster and chromis to bluefin tuna, many species have been part of plankton at an earlier time in their lives, be it as eggs, larvae, or in their youth. This breeding ground emerges moved by the change of temperature between the cold deep waters and the sun-warmed surface. This biothermal circuit is the engine of the Mediterranean and allows it to regenerate. Underwater peaks are an example of the abrupt encounter between a plethora of nutrients rising from the depths and the continental shelf, causing a proliferation of both pelagic and benthic species that benefit from their privileged position. These barracudas, like many other open water hunters, spawn by dropping their offspring en masse at the whim of sea currents, knowing that most of their eggs will be devoured even before being fertilized by hordes of small fish. These, in turn, will be fed upon by their own kind as well as by other predators. Mediterranean barracudas, jack mackerels, gilt-head sea bream, and the common dentex are designed by evolution to move almost without effort and accelerate within tenths of a second thanks to their robust caudal fins. In open waters, they tend to travel in groups. When they reach these heights, they spread out to hunt. Blankets of algae and the nooks and crannies within rocks are favorite locations for benthic species in which to lay their eggs. Although not even the careful damselfish will be completely safe from pillaging, these ornate wrasses have found a cavity in which the female laid her eggs, and not even the male's characteristic aggressiveness can avoid plundering. By coordinating the moment at which spawning takes place, the damselfish ensures that enough will survive to maintain their population. Their success is evinced by the fact that they are one of the most extended and numerous families on the planet. Fish that are specialized at capturing worms, small crustaceans, and mollusks among rocks and algae, such as sargo and hardheads, also find plenty of food in these submerged peaks. These fertile places, where different densities of water and currents collide with prominent geologic features, are a true meeting point for innumerable species belonging to very diverse biotopes. Many arrive here dragged by or taking advantage of the unstoppable flow of currents. They come from great distances to coincide with optimum tides. Others are permanent residents of these submerged islands with an amazing biodiversity that play a vital role in energy exchange. In Latin, Mar Mediterraneum means sea in the midst of land. With a surface area of 2.5 million kilometers, it is the largest inland sea on the planet. And of its 46,000 kilometer long coastline, 40% can be found on countless archipelagos. The majority of the islands that we see today are peaks of the tallest of these enormous mountains, which emerge from the sea in cycles. Some of them, born of violent volcanic eruptions, are relatively recent. Others, sedimentary and karst, have been molded by time and by the sea over millions of years. As true oases in the desert, they constitute a resting place for many birds, which seasonally cross over the Mediterranean in their transcontinental migration. Here they have drinkable water and a place to rest. For residents, they represent a safe place in which to nest. Although what we see on the surface is just a small part of the Mediterranean's biological framework. Green and brown algae gather at the surface, where they can better undergo photosynthesis, creating fertile prairies and forests. They constitute an indirect source of food, a refuge, and a place for spawning for many organisms. Crustaceans such as large spiny spider crabs or this tiny Gibbs sea spider crab carefully adorn themselves with small remains of their environment to blend in and thus avoid being found by predators as they feed. Many wrasses usually rest hidden among the algae, within which they blend in perfectly. In spring, many of those wrasses meticulously prepare their nests. A lone male can build many in the environs of his territory with plant remains, small stones, and shells. These apparently chaotic accumulations will protect the eggs that the different females who are attracted by the male's effort will lay. They will then fertilize and care for them until they hatch. The Mediterranean tapeweed is an indispensable group of indigenous algae. These phanerogams understood over 100 million years ago that in order to cling onto a substrate, they had to grow roots and reproduce through flowering. When the Mediterranean was formed, they adapted perfectly well to its coastal seabeds and mild temperatures. Today, they play an important role as sediment stabilizers and primary food chain links. This great mollusk is encrusted in the soft substrate that came about from the accumulation of calcarean remains in the knots of roots and rhizomes of the Mediterranean tapeweed. The firmly anchored noble pen shell filters organic particles supplied by currents, from which it extracts the chalky sediments to make its shell, which can grow up to 80 centimeters. The dense prairies of Mediterranean tapeweeds constitute one of the ocean's most productive marine ecosystems. They are the habitat of a large number of closely linked species, so their erosion would gravely endanger the entire group, beginning with the most vulnerable species. The most abrupt cliffs of the islands of the Mediterranean coast house various populations of birds of prey. They make their reproductive and migratory cycles coincide with those of marine birds so they can prey on their chicks. This young peregrine falcon female seeks out new hunting grounds. While the more veteran couples lay their eggs year after year in the same ledges of these marine cliffs. Kestrels, peregrine falcons, and even Eleonora's falcons, originally from Madagascar, feed off a seasonal flow of travelers from other continents. Over 2 billion birds of some 150 species cross over the Mediterranean along their annual migration and pay a small bird of prey toll along the way. Island cliffs, lacking nest predators like rats, are taken advantage of by varying species of marine birds to establish colonies of offspring. From the beginning of spring and well into the summer, one can find in dense nesting areas, with chicks in different stages of development, the yellow-legged gull, the most extended bird in the Mediterranean. These gulls are very territorial and aggressive, which is why they displace other species, often preying on their nests. What's more, they've gotten used to eating in landfills, where they find food year-round. After 26 days of incubation, when oxygen and space inside the egg becomes scarce, the chick, encouraged by parents who call it with insistence and whose voice it recognizes among the colony's clamor, emerges thanks to a hard protuberance on its beak, known as an egg tooth, that helps it break the shell. They usually have 2 to 3 chicks that leave the nest within a few days, moving about its environs while they wait for their parents, who feed them incessantly. The Cory's shearwater is safe from seagulls only inside the caves it nests in. They take turns to delicately incubate and care for their offspring. Even then, they're frequent victims of pillaging by non-indigenous predators, such as cats or rats. Every 8 or 10 days, and always at night, the couple relieves each other. One goes out to sea to feed on pelagic fish, while the other remains protecting and warming their only egg. When the chick hatches in autumn, which will be born after a month of incubation, neither will step on dry land until next spring, when they return to the Mediterranean cliffs to reproduce. The increasingly scarce couples of cormorants are always on alert because of continuous threats from seagulls, which won't hesitate to finish off the defenseless chicks if they're left uncared for. The excessive success of a single species causes the demise of the rest with which it lives, as well as the degradation of the habitat they share. Many islands benefit both from organic material supplied by ocean currents and that dumped in by rivers, which favors the proliferation of animals that feed on particles in suspension, scavengers, and naturally all those who feed on them. order to capture particles in suspension, this spirograph worm expands its spiral tongue with hundreds of tiny barb-filled filaments to trap nutrients brought in by the currents. Lobsters constitute a segment of the army of scavenger crustaceans that tirelessly clean the Mediterranean seabed. From brown crabs to many species of shrimp, they transform decomposing matter into protein, since they themselves are a part of a very important diet for many others. The lobster's only defenses are its antennae and its spiny exoskeleton, which it must shed periodically when it gets too small. Many of these benthic crustaceans are a part of the Serranidae diets, a widespread family with members that measure between 10 centimeters and 2 meters long, such as the cherna, which inhabits deeper waters. Groupers, which can weigh up to 50 kilograms and can measure 1.5 meters long, live in coastal waters or those with rocky sea bottoms, inhabiting the many caves of the Mediterranean coastal landscape. They feed voraciously off crustaceans, cephalopods, and even off smaller individuals of their same species. This super predator finds itself at the top of the food chain, which makes it a good bioindicator of environmental equilibrium. Unfortunately, many coasts have been deprived of their presence, or they become scarce because of sport and commercial fishing. In the walls that are most exposed to currents, nutrients flow with great intensity, only to be intercepted by an endless number of minute tentacles and arms. Sea fans make up true forest colonies with 1 meter long branches, thus creating a highly specialized biotope in its environs. What seem like flowers are really coral polyps that live in community, capturing microorganisms and particles in suspension. These seabeds are covered with embedded colonies of diverse species, some more widespread than others, which have reached similar feeding solutions. While sponges and sea squirts are poriferous filters, anemone, anthozoa, and bryozoa actively capture their food. These encrusted yellow anemone of up to 2 centimeters in length are united by rigid bases that anchor them to the substrate. Most use the solid remains of their prey as a resource to build structures of varying hardness. They don't, however, reach the size of their warm water cousins. Coral communities in the Mediterranean are equally productive, undergoing vital bioconstruction tasks. The calcareous skeleton of the coveted Mediterranean red coral grows very slowly, from 3 to 5 millimeters a year, which makes its regeneration difficult. Up to the 20th century, great Anthozoan forests could still be found, which man has used to adorn himself for over 30,000 years. Nowadays, it's one of the most threatened species in the Mediterranean because of commercial exploitation, which was, up to relatively recently, carried out by highly destructive methods, not only for corals, but also for the rest of the species with which it cohabits. Many species of benthic fish look for protection within the crevices covered by millions of polyps, sponges, and encrusted algae. Red scorpionfish are strongly territorial. Between May and August, their reproductive behavior becomes obvious. Like the grouper, this voracious nocturnal predator spawns far from the seabed so that currents and thermoclines can transport its eggs and colonize other places while they become part of the plankton. Adult male octopuses also wander about in search of receptive females with which to leave their genetic inheritance. During their meanderings, it's common for them to encounter other males with which they battle cruelly, sometimes severing a member or two. Females await the arrival of a male to fertilize their eggs, which will hang inside its lair, where she'll keep them as oxygenated, clean, and protected as her strength allows her. When they hatch and disperse, their mother will die of starvation and exhaustion. Then a century of crabs, shrimp, and other scavengers that she used to feed upon will in turn feed on her remains, thus closing the biological circle. In these waters, so rich in floating microorganisms, it's common to find many parasites on the skin of large and small fish. Like morays, many turn to the specialized help of fish and shrimp to get rid of bothersome guests and to keep clean. The interrelation between species and small and large-scale symbiosis are the fundamental pillars of the global ecosystem's sustainability. The Mediterranean is a sea of moderate currents and tides. However, with eternal insistence, the tides have sculpted the whimsical profile of its coastline. Beaches are formed in bays and coves by the accumulation of mineral sediments of diverse origins, more or less crushed by the strength of the waves. In order to avoid beach sand from being washed away by currents, it's essential that Mediterranean tapeweed prairies carry out their vital function of holding on to substrate, thus firming down dips to avoid the movement of submerged sands. This forms a firm base on which superficial sand can settle, so instead of being washed away, it accumulates. Thus, without tapeweed, the fine sand beaches of the Mediterranean wouldn't exist. Once more, two ecosystems, one underwater and the other on the surface, are closely linked. Toppled a long time ago, the former king of the Mediterranean beach, the monk seal, refuses to disappear from the planet. Fewer than 500 individuals are spread out in small communities between the coasts of Greece and Turkey, as well as a few dispersed locations on the North African coast, Mauritania, and Madeira. They are destined to disappear in agony because of the vast distances between their population and the drastic reduction of their vital space. Out of the water, beaches also need help to keep the sand relatively down pat. For that, they turn to the all-important vegetation, which creates dunes and terraces that prevent the sand from dispersing in the wind and protect many birds that come to the coasts to nest. The common tern travels thousands of miles to reproduce in warm Mediterranean temperatures. Their reproductive stages are synchronized with those of the fish they hunt. They are sure to find enough nutrients to feed their offspring in these rich coastal waters. The little tern usually prefers the more quiet waters of estuaries and deltas to procure nourishment. But both species nest in beach dunes more or less close to the shore, forming large communities that allow them to better control possible predators. The degradation and disappearance of coastal areas, along with the necessary conditions for their reproduction, seriously affect numerous birds and sea turtle species. Little red plovers, ruddy turnstones, and Audouin's gulls also nest in the coveted coastal margins, and they too have been seriously affected by human pressure that leaves them few places to quietly develop their populations. The vulnerable situation of the Audouin's gull presently makes it highly dependent on trawling flotsam, and the crisis in the fishing industry could seriously affect its population. In this enclosed sea, there is a prodigious biological diversity with a high degree of closely linked endemism. Unfortunately, many species are in grave danger due to pollution, overfishing, and the environment's devastation. Over the last few decades, we've almost done away with a natural inheritance millions of years old. Few are the mythical colossi that huff near these coasts inspiring legends anymore. The ancient sea of the Romans, the Mare Nostrum, isn't it still our sea? The sea that washes over 3 continents, that has seen the birth of hundreds of cultures since the origin of man, and that still feeds us. It's in our hands to learn from the mistakes and change our mindset, substituting our predatory attitude with another that is more sustainable and less aggressive with the environment. After thousands of years supplying enormous resources to empires that have ruled its coast at its expense, we now better understand the biological function of this small ocean. But we continue on without valuing the importance of its incredible biodiversity, without which the sea wouldn't be more than water and salt. And us? Who knows what would have become of us without our sea?